record to the cloud, and then when this is done, I can post these recordings on our journal club site. Um, so um, so let me kind of take you there just to share with you kind of my intent for the scope of what I'd like to do this summer, and I would like to continue this, for a long, long time, right? I think now my group in Espanola is just now getting over the hump of creating something, and we're getting we've never advertised, and we're getting almost a request per day for a pair of gloves.
Great.
And I know it's not a one size fits all. There's a lot of work to be done. Um, so let me just share my screen and show you. Um, you guys have all seen this already, but it'll just help me kind of organize my thoughts as well. And so if we go back to so am I indeed sharing the Journal Club page with you guys? Can you see
Yes.
it?
Yes.
Okay, gotcha. Um, so I've only fleshed out the first month. But so I really just see kind of today as a chance for orientation to kind of all of us get on the same page. Um, and also to share with you, kind of at least the beginnings of Parkinson's. I mean, you guys know way better than me. It's I mean, it's an awful kind of man-made crisis that we've created, and I don't really want to kind of go down. I don't want to talk about the depressing side. I want to focus on treatment, right? So and also the group of makers that I work with. So Chuck and Jade are with us tonight. We are not physicians or medical doctors, but nonetheless, there seems to be this treatment on the horizon, that folks can make with off-the-shelf parts that has had an impact on some people, Kanwar, for example, right among us. And so I want to use tonight just to kind of establish the vocabulary. Um, what do we know about Parkinson's in the big picture, and then also maybe to share with you, my passion for this one amazing book. Um, the book is largely this book called Ending Parkinson's Disease, right? So I can just kind of click on it right now. You can order the book, watch the documentary. Um, four authors that are really pissed. That this is a man-made disaster that we're not really doing enough about, and so they call it a prescription for action. Um, and which is for sure what I hope is happening with the group I work with in Espanola. But the action they're calling for largely in this book, are for citizens to kind of rise up and share their concern, that we continue to poison the environment with air pollution, with weed killers, and with industrial solvents like TCE. And so the book is really trying to kind of speak to activate citizens, to activate their legislatures, to change laws that can save lives. Um, because the downer is it's the fastest growing neurological disorder in the world, so the numbers are just going to increase. Um, folks in the developed world have access to some drugs that have some good effects, but folks outside of the developed world don't really have access to these drugs. And so it really is a prescription for action. It's a really powerful book. Um, but it's also, in my role as a teacher, and if I'm trying to radicalize students or my community, it's super important to have things you can actually do, right, about it, rather than just, being angry. And and then there's a number of treatments on the horizon. A lot of them, for sure, are coming from some stem cells, and things that really require years and years of study of biochemistry and medical science and epidemiology, not to mention computing and statistics. So I find all those avenues super super important. I'm a definite believer in in Western science, um, but there are these simpler treatments like what I want to get towards, right? And so if I kind of move back to our page, so I hope, and by discussing chapter one tonight, 45 minutes for an hour, however long we choose to discuss, we can kind of lay the groundwork that will help us begin to think more carefully about neuroanatomy and understand this much more challenging paper that I'd like to read for next week, right? So next week, I really would like to step through the kind of the major paper by the TAS lab at Stanford on coordinated reset vibrotactile stimulation. And this was, something, yeah, a very small clinical study, um, but it's a pretty ambitious paper. And also for my students as well, I'm also trying to help them understand even how to read the medical literature, or help all of us read the medical literature. My background is there's many folks here that I've only had like sparse communication with. Um, so I I studied electrical engineering as an undergraduate, and I got my master's in electrical engineering. My advisor was a closet mathematician. He recognized that my need to kind of go deeper, and so I pursued a PhD in mathematics. That happened in 1988. From 1988 to 2016, I was a professor of mathematics at Rice University in Houston. For 10 of those years, I was also an adjunct professor in neuroscience at Baylor College of Medicine. Um, and so I've had a long kind of abiding interest in in kind of the mathematics of the brain and kind of single cell biophysics, the things that we know best. Um, Systemic diseases that affect the whole brain and the whole nervous system, something like Parkinson's, is a much more ambitious undertaking than what I've ever grasped before. But this was kind of foisted upon me by a community member in my, in my town, and together we brought some relief to her husband, and my goal was to bring some relief, that kind of relief, to a much broader group. Um, so I come out of math and science and neuroscience, and moving to Espanola 10 years ago to work with less developed ecosystems where STEM was not really being promoted in schools. Um, I turned from an academic to a maker, right? And for anyone that's received our glove, you see it's hand sewn, a lot of hand soldering, and it's been redesigned and redesigned and redesigned, and is still far from what it needs to be. Um, but it's worked for some people. So that's a little bit about my background. I think today should just be a very kind of gentle introduction, and next week will not be so gentle. But so maybe today I might unfortunately be doing too much of the talking. I really do wish for this to become a much more give and take, a much more conversation. And I expect there's going to be lots of issues in reading Tass's paper next week, where we should, maybe spend 20, 30 minutes on one figure, right? Or one sentence or one paragraph. Not to put Tass on a pedestal, right? But to really understand, or to help us understand, do we know what he's talking about? Um, and and do we see this in practice for the folks that are wearing these gloves based upon the task stimulus um, timings that have been programmed into the gloves that we're now distributing? So that's the July 7th kind of prognosis. And then with that kind of theory behind us, if we can do that in 1 week, or if we need to take longer, yeah, I want to spend as long as it takes to have a solid foundation before sharing with you our trajectory of how we've built the glove in Espanola, um, and how we've begun to design apps, and what shortcomings we see as makers, but especially what shortcomings you see as participants um, in this social enterprise. Um, and then so my real hope, right, is that in starting after this month, is to begin to, in engineering, they talk about closing the loop. Lots of people talk about closing the loop, but it's especially important in engineering. So the glove is a device that sends a fixed but random stimulus pattern into the fingertips, um, and that pattern was what Tass in a small clinical study found to be the most efficacious. Um, as far as reducing symptoms for Parkinson's. Now, to close the loop is to actually tie those stimulus patterns to sensors on your body that are sensing the effect of the gloves, right? And so if we can sense your voice or your gait or even your electromyogram, right? So there are now surface electrodes where we can listen to muscles all passively. Um, and these things are now getting extremely inexpensive. And my group is beginning to explore how we can build these and add them to the glove. So the real key is adding to the glove sensors like accelerometers or EMG or microphones that are recording your symptoms. Um, and instead of sending, I mean, it's not a bad idea to send those recordings to your neurologist, but I'm not sure how often you guys are able to get into the city to see a neurologist. But there's no reason why those readings can't be used to make the minor adjustments that keep the stimulus kind of in the sweet spot. Um, as your disease progresses, we've got folks online now of many different ages and different years of diagnosis. So I really can't imagine that one size fits all. Um, and so, but at the end of our schedule there, and again, I intend for the schedule to go on into um, for the rest of our lives. Um, but on the 21st, we'll begin looking at kind of freezing of gait. How do we detect it, and how do we manage it? You're all quite, well aware of what it means for your gait to freeze. And yes, it can be detected by a neurologist. It can be detected by any person who's kind of watching what's going on. It can be seen. Um, can it be detected before it happens? And can during its detection, does that give us some indication about where to move the sliders on the app that David has now been kind of using for the past couple of weeks? I'm very curious, David, to get some feedback. Eventually, you don't have to, I don't mean to put you on the spot, but there's the hope that if we can change these settings, that the effects of this vibrotactile stimulation need not wear off because they're going to be tied to measurements, and not measurements of some abstract, case study, but measurements of your own, right? That are meant to be non-invasive and just kind of rich with information, and that do not require you, to drive into the city to spend, what yada yada, how many minutes or hours you can with a neurologist. Um, I also I hope you didn't kind of sense any negativity in that one. So I'm I'm I am negative about how difficult it is for people to get healthcare. I'm not at all critical at the quality of neurologists that are here. We have too few neurologists per person suffering from Parkinson's or suffering period. So I would like to grow the healthcare system. So I hope in my zeal for getting something that's going to meet the demand, I'm not at all trying to tip over the apple cart of the Western medical system, right? I'm just trying to bring more people into that system, um, and largely my students and my fellow coworkers in northern New Mexico. So that's um, that's my story. That's why I brought you all here for this kind of, Monday evening chat. Um, I'm happy to jump into to what I've highlighted in the coolest parts of chapter 1 of this amazing book on ending Parkinson's. Um, but before doing that, I want to open it up to other people's comments on kind of first of all, I mean, is this something that sounds interesting, something you'd like to do? Is there something that's missing, something you wish we would be able to do on such sessions? Um, is this going to kind of get too technical? Is it just for makers? Do we want to have maybe a separate meeting on occasion where the participants, can kind of share their insights, or is that something you can do through chat? I guess this is our maiden voyage, right? And I don't just want to hat off on the direction that Steve has chosen. Um, so I'm really curious about where you guys think this could possibly take us, your ideas.
Well, I'm here because I don't really understand any of the science, and I welcome the opportunity to learn about it. Um,
Thanks, Judith.
yeah.
Stephen, how many people have the glove on this call?
Um, it's a good question. Let me look at the big picture. Yeah, so I see one, two, I guess maybe people could even self-identify, right? Because it was probably as Ken knows, it was getting a little bit too much for me to manage kind of the making of the glove as well as dealing with participants coming in and out. So my wife Laura and Minna here have done a lot of work with kind of with participant intake and sending out the glove. So I know Kanwar and David, you have gloves. And Judith, you have yours as well?
I do. I haven't had a chance to try them at
Gotcha.
all, but I've got
Okay.
them.
Gotcha.
Yeah.
Gotcha.
I wonder if we
And
could go back to take off the shared screen so we can see each other.
yeah. Sorry. Let me do that. Yes. Yeah.
Yeah, thank you.
Thanks, Judith. Yeah. So Kelly, Willie, I know David has a pair. Andrea.
This is Mike on Willie.
Okay.
I have not gotten the gloves yet, but I've been interested in the gloves, been researching anything I could about Parkinson's. I was diagnosed in February 21, at like 53 years of age. So I'm doing anything I can find to be proactive. So mostly right now, I'm very heavy in exercise, and I found that has kept things from progressing whatsoever.
Gotcha. Thank you, Mike.
I have to commend you and your team on the efforts you made in putting these gloves together because when I got it, I was very excited. I saw the footprint was much smaller than the cast gloves, but they work. Ken and I were together a couple of weeks ago, and we were playing around with it, and the pressure that's applied on the fingertips is just like the task gloves. So it's very similar.
Gotcha. Gotcha. Well, that's great feedback, Anwar. I mean, I've been anxious to, um, to hear from you on that count.
And it works. It works. Now,
Yeah.
the thing is that what I found in my 8 years of using the glove, the past gloves, is it doesn't work for everyone at the same level. There's,
Yeah.
in fact, when they look at their UPDRS scores, but
Mhm.
not everyone gets the same improvement.
Yeah. 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 So I'm really hoping, that through the app that I've developed and then through the biosensors they're going to be coming in the next 6 months, that we can begin to tune this to literally personalize this thing. And so, for example, I mean, David at least in the center of my screen, has heightened sensitivity to stimuli. Um, and he found the vibrations much too large, and so we were able to dial back the stimulus, um, and also we'll see this next week. But even in the task study, the previous studies to task used a vibration about 3 times the size of what task did, and there are some that even have crazy titles like imperceptible vibrations, being kind of which just sounds like too good to be true. And so that's a direction we need to be going. And I now, with a large enough data set and a large enough folks, kind of investing in these possibilities, I'm confident that, yeah, I don't really know the size of the sweet spot, Conrad, for sure, right? For different people that, different levels of severity, different number of losses of neurons in substantia nigra. There's maybe only so much these vibrations can do, but I think they've yet to be explored about how best. So Toss found a sweet spot for your clinical trials,
The
and
thing I would add though is what he's got is on his device he's got a chip that goes in, so it's low
uh
and high intensity. So he's varied it that way, customized it for people with 3 settings.
Uh-huh.
Oh.
Gotcha. Yeah, I didn't realize there were, so you had some control of the settings that you were wearing?
I don't have control, but it's a chip that he puts in. It's like a
Gotcha.
USB chip.
Yeah.
So basically, when I first started out, I didn't have good sensitivity on my fingertips, so I needed the high intensity one.
Uh-huh.
That gave me an impact, and then we did both hands. Some patients you only did one hand, depending on left or right. And then, as I started getting a sense of touch and feeling and sensitivity, it was too strong for me. And then he went to medium setting, and now I'm on
Gotcha.
low setting.
Mm-hmm. Gotcha. And
Yeah,
the gloves the gloves of ours that you're trying, are they kind of in the middle then of those settings? What's your,
Middle.
yeah, gotcha. Okay. David, were you going to speak?
yeah, I was gonna say the first set of gloves, as you said, were overwhelming for me. I get tired using them, and new ones had it at the lowest settings. And I'm working on a letter I was gonna give you that tells you a bunch of stuff, but I can set them myself, and I'm able to use them. It's actually relaxing to me now, and I'm seeing some positive results. I have more energy, and I've actually had periods where I felt normal, which was amazing.
Wow. Wow.
And, so I'm a happy user now.
Gotcha.
And I feel like it's getting stronger. The more I use it, the more I'm easing into it. So good stuff, Steve.
Wow. It's great to see you smile, David. Wonderful. Thank
Yeah.
you. Thank you so much. Yeah.
I'm Kelly.
Hi, Kelly.
Hi. You can't see me because I don't know how to work it. So I have to figure it out. I'm feel proud that I got the microphone.
Yeah. Your voice is loud and clear. Yeah. So
Okay, good.
do you have a
So,
pair of gloves? Do you have a pair of gloves, Kelly?
No, I'm on the wait
On the
list.
wait-
We got a
gotcha.
note saying coming soon.
Okay. Okay.
My husband read an article about this, and we sent in some information to you, whatever you asked for, and then you said you had people out because it was the summer or whatever.
Yeah.
But it just I was diagnosed in 2017,
Mm-hmm.
and I do know that a lot of exercise is helpful. And I've just had a couple of falls that have made me not as able to exercise as before. And I noticed that I'm losing a little bit more of what I had. So I'm here to see what this is all about because I didn't quite get the whole picture. And then when you said the Zoom thing was like, and my husband is here. He's my biggest fan.
Gotcha.
So we're trying to keep me upright and doing my own thing for as long as we can.
Gotcha.
So I'm real happy to find this.
Wow.
People are talking about somebody that actually adjusts the gloves for their personal situation. Are these the people in Espanola that do that, or is it their neurologist that's doing it? Who's making those adjustments?
Yeah, that's a good question. Yeah, so it's that. So far it's just kind of David and I. David's on our screen now, and so there is. I've developed an app just for Android phones. And this summer I hope to move it to iPhones. So it's an app where you can do the settings yourself. Husband of Kelly, right? And so, and again, I'm all these things should come with a million caveats, right? I mean, so this is probably like a really like dangerous thing for me to be doing, to be pushing all this stuff, but the need is there. And so I don't know what settings to be chosen. I know what settings Toss chose because those are published, right? And that was somehow an approved study. What we're doing is kind of frontier neuroengineering, and it's so I'm very sensitive about kind of experimenting with people's lives, but I do want to give people the chance to move around these kind of timing parameters, right? And so I know you guys don't have the glove yet, Kelly, but we're not injecting. I mean, it's not a drug. There's no penetration. There's no electricity. So there is electricity that drives a motor, and the motor vibrates the fingers. And so we're giving people through this app, which I'm really happy to push out is to as many people as possible, especially now kind of giving David's feedback. This app, and we'll look at these timing patterns in detail next time, right? It's a little bit, maybe it kind of it's a little bit advanced for I think for today, but there's no reason we can't go there. But so TAS published these timing patterns. The time says so each finger gets buzzed for a tenth of a second, and the buzz makes an indentation in the finger at about a tenth of a millimeter, right? So it's a very small indentation for a very short amount of time, and then those buzzes move across the other fingers in as random as a way as possible. And that randomness is supposed to scramble the bad rhythms that get set up in your motor cortex by the lack of dopamine. So without dopamine, there are these 20 hertz vibrations. And while someone's playing 20 hertz into your head, you are not able to exercise voluntary movement because something else is scrambling those things. So the fingertips are meant to somehow, the fingertip vibrations should help to descramble. But as Kanwar was saying, depending upon where you are in your progression of Parkinson's, that the one pattern that we're sending out with the glove, may not be the one that will be most effective. So does that make sense, husband of Kelly, what I'm talking about? Yeah.
Yeah.
So I'm giving you the ability to change those patterns.
Right.
Now,
I can
of course, I really highly recommend that you do that in concert with your neurologist, right? That
Right.
I really want them to understand, if possible, that what you're experimenting with, and have them help direct those.
And is there any particular thing like a URL or something? I'm going to go see my neurologist on the 15th in Albuquerque, and I participated in a thing called M360 that is exercise oriented, and found that useful. And she knew about it, and so it was nice to be able to talk and have her know what we were talking about. And I'd like to find out what she thinks about this. How soon do you think gloves will be available?
That's a good question. So Laura just left to make dinner. I'm not sure where you are on the list, Kelly. I know before I left Espanola last week, we got parts in for 25 more pair. And I know there are about 30, I think it's about 30 people on the waiting list. So we're pretty close to
I could be in that 25.
you could be, yeah. But the last thing I want is give people like false hopes. And so but you're if you're not in that, then you're in the next batch, which will be within the next 2 months. So in talking to your neurologist, I mean, if you just share with them our Espanola GloveWorks site, and so that and maybe in the reference to the TOS paper that's part of here at the Journal Club, there's if the doctor has never heard of these gloves, it may help to show them the video that's on our site about how to wear and charge the glove, because then the person, or in fact, the best place to go is the video of Kanwar, so which is also on our Espanola GloveWorks site, perhaps a little bit buried.
Okay.
And so,
well, I'm here. I'm ready to participate.
Thank you.
So is that video the one that's on the page we were just looking at? Yeah.
No, I guess the video's not there. It's kind of back on our main page.
Okay.
Have you seen the video for how to wear and charge the glove, Judith? Because you said you received. Okay, gotcha.
No.
We haven't.
Okay.
We've just seen a still picture of something.
Gotcha.
The gloves.
So so I can show you guys that before we sign off tonight.
Okay.
All right. Good.
Okay. Because she's pretty knowledgeable, so.
Cool.
Yeah, I've seen it already. Yeah.
And Andrea, how about what is your story? Do you have a pair of gloves?
I'm actually a home health nurse, and I have a patient that I work with, and I had seen the article in the Rio Grande Sun, and I
Gotcha.
just, yeah, so yeah, I was just
Okay.
for myself just trying to uh learn about more about Parkinson's and how I can help him. So
Gotcha. Gotcha. Is this the gentleman in Kundio?
yes.
Okay. Gotcha. Gotcha. Yeah. So I met his daughter when I brought over the gloves, and so
Okay.
do you have a quick update on how he's doing?
You know what? Yeah, he's doing well. I mean, we've been just, taking note of his what we notice or what we don't notice. And for the most part, he seems to have more energy, and hearing that exercise seems to help. I've
Mhm.
noticed that as well. We got him an exercise bike, and just trying to do particular, I guess, exercises. I saw through the foundation, I think it was through Canada's Parkinson's Foundation, we found some exercises to do specific exercises. So I mean, he's doing well, and I told him about the class that I was going to be taking tonight, and he was looking forward to hear what I
Cool.
was
Cool.
going to learn. So that's really neat
Gotcha.
that you're recording that. So I'll be able to share this with the family if that's okay. And
Great. Great. Please, please, please. Yes.
yeah,
Yeah.
and
Yeah.
and I look forward to signing on Mondays. So
Okay.
we'll continue
Wonderful.
to learn.
Wonderful. Great to meet you, Andrea. Yeah.
Nice to meet you. Thank you, guys.
Um, Ken, please.
Yeah, as you know, I've been playing with building gloves for over a year. And the piece that I've always felt weakest in is the pattern,
Hmm.
the root of it. In other words, the sequence.
Yeah. Yeah.
Because I'm not a neurologist, and that is where I think you come in and Peter Tass comes in, and that's the weakness.
Hmm.
But one thing I did, which I was pretty proud of, at one point when I went up to Conwars 2 weeks ago, basically he had 3 pairs of different gloves in one place. We had
Hmm.
the Peter Task glove, we had your glove, and we had the glove that we make here in Fort Lauderdale. And I like your glove because of the pattern, but if you look at the Peter Task gloves, which stood Conwar in good stead for 8 years,
Hmm.
they're built like a fortress.
Yes. Yes.
They lasted 8 years, and a few screws came out, which we straightened them out. And he's back in business.
Hmm. Hmm.
Your glove has got an incredible vibration. It's elegant design, but it's just not going to be durable. It slides. I mean, Conmore will go marching down the highway with his hands flailing back and forth, I'm sure.
Hmm.
So I all I would say is, and nothing worse than somebody telling you how to reinvent the wheel. Durability is key because whether you like it or not, people are going to want to open a glass of juice or just anything.
Yeah.
So I would say even if it means you spend a little bit more money, I think just make it a little bit more durable.
That's a great observation, Ken.
And
Yeah.
that's what I did. I actually took Conwar's gloves.
Uh-huh. Uh-huh.
He's going in for, well, I'll let him talk about it. And what we did was we took them, and I'm a big bicycle glove fan, and we basically just added it to the bicycle gloves.
Hmm. Hmm.
And it's worked out great because the bicycle glove you just gives me adjustment, and then your little box there, it's so light and small you can just attach that with Velcro.
Yeah. Yeah.
So
Gotcha.
just made it a bit more durable, and so that it doesn't slide on your wrist.
Gotcha.
But I love the vibration pattern. I do think, like you said in one of your videos, you might have gone too small. I mean, this little on-off button is very
Yeah.
fragile.
Yeah. Yeah. Yeah.
But like I said, I'm an engineer by background. I don't like people telling me what I did right and wrong. So I'm not telling you to you. I think it's a magnificent product, and I think there's a real shortage of attention to this technology.
Yeah.
If anything,
Yeah.
we've gone backwards. Less people are involved with it than there were 9 years ago.
Yeah, yeah, that's bizarre. I can't understand that. But it's for sure. I mean, the robustness and durability is a gigantic one. We've done some repairs, right? And it's just not it's expensive for everybody, right? So we need to
Oh
do
yeah,
it.
you don't want to
We
be
need
repairing them.
we have to do it right the first time. So I really appreciate that, Ken.
And then just one other thing, real quickly, I'd
Yeah.
say is don't get hung up about improving the glove. The glove as it stands today can help a lot of people. And that's
Mhm.
what Peter Tass does. He's getting all complicated and feedback in the brain. His basic glove that Conmar wore for 9 years just did the job. Get some of those out, and then you get some interest in this again.
Gotcha. Good. Yeah, that's yeah, and kind of managing the team as it grows. There are some that always want to keep on making it smaller and working on the next level. And then I just need to get some just to kind of fix the workflow, right? To make sure that it's robust and
Get a
tested.
Chevy out there and drive it.
Yeah. No, that makes a lot of sense. I'm with you. Good. So I think we've all had a chance to kind of introduce ourselves and to kind of there's a broad cross section of experience here, and so I'm super grateful for this input. Can we open the book and take a look at kind of this kind of Parkinson's 101, just kind of establish this kind of common vocabulary for all of us, and then that'll prepare us for the kind of deeper dive into Toss's paper for next week. And to do that, I will like to share the screen so I can point out kind of salient parts of the text as we read it together. But if at any time you want to kind of come back and see some faces and kind of get your head out of the book, please just don't hesitate to say, Steve, come on, let's get back to the Hollywood squares. So let me reshare. And yeah, so I think I took you to the I took you to the site, right, where the book is available. You can buy it at in lots of places. For those that don't feel that they can afford a copy or they want to send a copy to someone else, the authors are offering to send you a copy for free. So from that link that I showed you on Ending Parkinson's Now, all proceeds are going to Parkinson's research. They're not pocketing any of the proceeds of the money. The lead author, Ray Dorsey, has an amazing set of YouTube videos. I mean, he's pissed. I mean, he is on on a serious piece of work to change the laws in this country about what chemicals we expose ourselves to. So anyway, so this is the first chapter, and largely, and you guys let me know if I need to kind of to go a little bit to zoom in or zoom out. Is that big enough for you guys to see what's on the screen right now?
Yes.
Yeah.
Okay.
Yes.
Gotcha. So, yeah. So medical science, I mean, the human condition's been around for, hundreds of thousands, maybe millions of years. Parkinson's is something quite recent. It was not diagnosed until 1817, and it seems to largely be a consequence of the Industrial Revolution. So, without regulation in the center of industry, which happened to be England in the late 1700s, early 1800s, the air pollution was thick, and it generated lots and lots of diseases, lots and lots of social maladies, even crime. It's easier to commit crimes in the haze and the fog. And so in 1817, this doctor, James Parkinson's, kind of wrote an essay on something called the shaking palsy, identified largely, with tremor and the most kind of obvious symptoms of Parkinson's. And so things begin in 1817. There are some tangential references in earlier literature, East and West, but nothing is detailed that we really think that this is the beginning of the research or the identification of Parkinson's. And so this chapter is, kind of largely stepping us through that timeline. In fact, maybe the best take-home message is the timeline that comes in a couple of pages. Some of us may find that timeline a little bit dense, so that the chapter kind of unpacks the timeline. So 1817 in the text that I've highlighted, right, is this say on shaking palsy. It's not for another quite a while longer, right? Not until the 1950s, that we being the scientific establishment, begin to make some inroads into what can be causing, what are the things that are responsible for this palsy. And in the 50s, there was, significant, well, basically in all the 20th century, the research on neuroscience is just explosive, what we now know about the brain. Dopamine was not one of the first things we found out about the brain. Its action, it's not one of the primary neurotransmitters. Its effect is still largely mysterious. And so it took some time for dopamine to really be identified as kind of the missing chemical in the brain that caused the Parkinson's symptoms. And so, and that was, and again, that early research, again, it's not ethical to do work on human brains. So it was first found that they could restrict the amount of dopamine in a rabbit brain. And by lowering dopamine levels, this is the highlighted text I'm pointing to here, by lowering dopamine levels in the rabbit, they were able to induce what seemed to be kind of a sedative or rigidity in the rabbit, right? So this is, evidence that dopamine is implicated, and I guess from there, it was kind of a jump to see, that you can't really restrict dopamine in patients like you could with a rabbit, but you could go to patients with, say, with Parkinson's or even severe Parkinson's and see if a precursor to dopamine, something discovered L-DOPA, is a chemical that the brain uses to synthesize dopamine. So if you introduce more L-DOPA into the body, can that be used to relieve Parkinson's symptoms? And for many of you on this call, you are probably taking some form of levodopa, or your neurologist is trying to hold off until having to do that. But the early results were just miraculous. So one of the first to study it, Cortzius, calls it a true miracle drug of our age, right? And so, and the promise of that drug, to maybe go, I might just kind of go back to our webpage. And so, I hope that a lot of people have maybe seen the movie Awakenings. So it's about a young British doctor, Oliver Sacks, in New York. After seeing Kotzius' kind of early work with Parkinson's and L-DOPA, he gave it to patients, largely catatonic patients who hardly were even moving. And they literally, kind of rose from their chairs. And it's such a powerful, powerful thing to see. And so I've got that in a historical video clip, which I'm highlighting here on a journal club page. So if you want to see these kind of spectacular early success of L-DOPA, so it has a downside. It leads to a number of difficult symptoms. The brain habituates, so the neurologist's ability to kind of find the right dosage at the right stage of your Parkinson's remains more of an art than a science. But to see how drastic the relief was for people on L-DOPA, it still is it still is the dominant treatment for Parkinson's. So there are drugs, there's surgery, and then there's vibration, right? And the theme of what we're talking about is largely vibration. But I wanted to, but part of the story of Parkinson's is is the discovery of kind of dopamine as the missing chemical in the brain. And to better, and again, so you can give L-DOPA to folks, but you can't really see what it's doing in there other than changing their symptoms. But on autopsy of Parkinson's patients, they could see that the brain of a normal person has two bands, right and left band of a kind of brain area called the substantia nigra for the black stuff. And normal patients in histology upon an autopsy have these black things, and these are shrunk and largely missing in Parkinson's patients. So it's a little counterintuitive. The dark stuff is good, right? And the light stuff means that these cells that are forming this dark matter are missing in Parkinson's patients. It so happens that the cells in this dark stuff are the cells that create and synthesize dopamine. They're the cells that send dopamine throughout the brain. And these are deep, deep inside, just right at the top of the brainstem. I'm not sure if you can see my pointer as I'm kind of moving it around inside the brain. So, in Parkinson's, these cells in substantia nigra die. And those cells that produce dopamine are then not able to deliver dopamine to the circuits that need it. And some of the circuits that need dopamine are the circuits that control movement, especially voluntary movement. And so it's the beginning of a story of how Parkinson's affects the body. These cells die. These cells produce dopamine. You need dopamine for movement. So the next part of the story is what is killing these cells. Okay. Are we clear on that so far? So cells die, and we want to know how do these cells die? And again, we're dealing with human subjects. We're also dealing with structures in the brain that are very, very deep, right? They're not accessible to imaging or to electrodes from the top, right? And so we need some kind of indirect evidence to understand kind of cell death. Okay, so there, it's a really captivating piece of writing I find in this first chapter, this kind of detective story, and so that it's largely kind of taking advantage of other people that got Parkinson's via a side door. So there are kind of two stories in here, and one is that, and they're both basically related to kind of drug addicts taking kind of tainted drugs or even cooking up their own concoction, and all of a sudden poisoning themselves. And so there was a bad shipment of heroin moving along the streets in San Jose in the early 80s that affected half a dozen folks. And overnight, cells in the substantia nigra were killed by the drug they were taking. So they got instant Parkinson's. And as you all know, Parkinson's is not reversible. So I mean, just because you can get it instantly doesn't mean you can instantly turn it away. Otherwise, we wouldn't be here tonight. And so these are super tragic stories, but that gave kind of biochemists and neuroscientists a formula for how to create a drug that that gives people Parkinson's. And so now there are two things you can do with that. You can say, oh, well, this drug looks like something in the environment. I wonder, are we already giving people Parkinson's? Another thing you can do with that drug is give that drug to other animals and see if they develop Parkinson's, and then see what you can do to ameliorate their symptoms. And that's what happens in the rest of this story on kind of the detective story. So they do two things. The first is they now have this chemical MTTP or MPTP, sorry, and its relative MPP plus, and they notice that it has a chemical structure very similar to Roundup, the pesticide called paraquat, and the weed killer called paraquat, called Roundup. And so this generated the hypothesis, are these pesticides partially responsible for the prevalence of Parkinson's in industrialized society? And they find, the stats are here. So maybe I'm kind of highlighting too much stuff, but they highlight the fact, yeah, so here it's in the bottom one, right? They found that farmers, I'm kind of down on the bottom right to the screen, farmers to use specific pesticides, including paraquat, were more than twice as likely to develop Parkinson's as those who did not, right? And so twice as likely. And again, there's a lot of medical science. As you guys begin to read the literature, it's all probabilities, right? I mean, not everyone exposed to these chemicals will get Parkinson's. They make the great case, that not every smoker gets lung disease, gets lung cancer, but it increases your chances, X fold, right? And X depends upon exactly, the pesticides they have it, and also how it interacts with your genes, right? And so here it was, that they could give this chemical to rats and induce Parkinson's, and they recognized that this chemical looks a whole lot like paraquat, like weed killer or pesticides, and so this ought to be something that kind of informs our use of those chemicals. That's on the environmental side, and all coming through the side door, right, of patients who just got Parkinson's, overnight. And there were and people began to connect the dots, right? So again, we're super fortunate that have the kind of sophistication in medical science that these insights don't kind of fall through the cracks. Um, um, that said, that doesn't. It's still not clear. I guess that we'll look at a stat in a minute. So currently, it looks like maybe only 10% are probably due entirely to genetics, but there are genetic markers, and so they're typically done, by kind of watching Parkinson's travel through large families, and then finding what do these families have in common in their DNA. And what was found, again, this is quite recent work, in the late 90s, there is a mutation on a certain gene that creates alpha-synuclein, right? And so synuclein means these are proteins that are involved with moving neurotransmitter out of the cell. 1% of the brain is made up of this protein. This is a highly, highly abundant protein. And so when this thing gets mutated, it's not a surprise, that could wreak havoc on the normal brain. And so this has been identified in 1997, and it truly is kind of the smoking gun. It turns out that when this gene is mutated, it misfolds, and this misfolded protein does not do its normal function, which is already bad enough, but it actually kind of clumps up into tangles very similar to the tangles that you may know from plaques and amyloid beta and Alzheimer's disease. So these misfolded proteins, they don't function properly. They're not cleaned up by the kind of garbage collection in the brain. They form tangles, and these tangles are found in autopsies inside substantia nigra cells that have died. So it's this misfolded protein, this mutation on a gene. And again, for folks, who want a little refresher on kind of even what is a gene, this is a lovely text. So a little box on kind of what is a gene. These are instructions for how to make proteins. Proteins are the building blocks of all life. And when proteins are not doing their job, there should be some kind of garbage collectors that remove them. And when that garbage collection goes wrong, we're in trouble. So there's a little box on what's a gene, and another little box on how misfolded proteins can lead to Parkinson's. So if they're not folded properly, if they're misfolded, they can hook together, and as they hook together, they begin to starve cells. How exactly they starve and kill cells is still part of the detective story. But as a partial excuse, that's a very deep detective story that really requires, expensive biochemical labs, and something that we're not going to be doing in our small group in Espanola. But nonetheless, it's super, super important to understand, kind of what are the processes. Okay, so kind of working backwards, we see kind of rigidity and freezing of gait and tremor is being caused by something messing with our motor control circuits. We then realize these motor control circuits need dopamine for their proper functioning, but the cells that make dopamine have been killed. The killer of those dopamine cells are tangles of misfolded proteins. Those proteins misfolded for two reasons. Either there's a mutation in the gene, or the environment has caused a mutation in the gene, right? So mutation in the gene that they inherited from their family, or a mutation that's inherited from the toxins in our environment. And so those misfolded proteins, as they clump, are called Lewy bodies. That's kind of down here at the the bottom. I'll highlight that one. Yeah, and I see we're approaching 9. We're getting very close to the kind of the final piece of the detective story. And again, it's definitely hubris to ever say final, but I see 9 o'clock approaching. The final piece of the story, right? We've worked all the way back. We found out what were the killers of these cells. We see you can inherit those mutations from in your family, but also if you receive them from the environment. So how does a pesticide come in and mess with your genes? And so that's the final piece of their story. And that's what they call an astonishing new hypothesis. And so the hypothesis is that some pathogen enters the body through the nose or the gut, right? And so as you breathe or you eat, something comes into the body and messes with gene regulation in your nose or in your stomach, triggering this normal protein to misfold. Okay, and so that's a pretty straightforward thing to check. The hard thing to figure out is, especially if it's in the gut, your gut is a long way from your brain. So how do misfolded proteins not only not picked up by garbage collectors, but even find their way up to the brain, right? And so it's still an ongoing story. And we'll look in kind of future papers to kind of, as we learn more about neuroanatomy, which I think is you can never know too much about how the body works, but there's a sympathetic nervous system that kind of uses the vagus nerve to regulate lots of things that we really don't want to have conscious control over. So the brain through the vagus nerve is controlling, is kind of, yeah, it's controlling digestion and breathing and heart rate. And controlling means it's measuring those things. So it's sending information down to the gut and down to the heart, and then receiving information back. And it seems that these misfolded alpha-synucleins are kind of hitching a ride in the vagus nerve and making their way up to the brainstem, finding a home in these cells in the substantia nigra that are killing the cells that make dopamine. And that then kind of connects how the environment and I guess for the nose it's even easier. There are other pathways. The olfactory cortex is kind of the super primitive brain. Smell was really an early thing that helped us survive on the Serengeti. So as environmental insults come in through the nose or through the gut, proteins are misfolding. Those misfolded tangles find their way to the brain. And what's also very, very kind of insidious about this disease is, unlike the drug addicts who got it overnight, this can take decades for these misfolded proteins to come up the vagus nerve, find their way to the brainstem, and slowly kill cells. And only once a certain fraction of cells die do you suffer these motor symptoms, right? And so the disease can be quite well along its way, which means, I mean, we know that the reason we're curing so many cancers is from early detection. And so part of something we should be talking about is early detection for Parkinson's. And being able to sense your gait and your voice and your muscle contractions through surface electrodes are tools in that toolkit for early detection of Parkinson's. I'm sorry that I sped up so much at the end, but I just hope that I kind of gave you a feeling for the power of their writing. I find their writing quite powerful. There's a sense of urgency, which again, I don't suffer from Parkinson's, but Minna here is on. Minna is a dear friend of mine. Her husband suffered of Parkinson's. I've seen, yeah, what it's done to families, and the sense of urgency just makes it's important to translate that into action, right? And so, and that action can be legislative. That action could also be making something that, as Ken said, these ideas have been out there for quite a while, and why there are not more gloves more hands is a mystery. So that's what I had planned for this evening. I'm really grateful for the early discussion.
Thank you.
Yes, thank you, Steve.
Yes, thank you.
Thank you, Steve. Is it possible to be on the East Coast that you could call a little earlier?
Too pushy and moving through the town. Yeah, that's another good thing to talk about. Yeah, is that something? I see my connection's kind of going unstable. Would people rather? So I'm on the far west coast. So I kind of chose 8 to kind of be in the middle. But I know for folks that are on the west coast or east coast, sorry, that's quite late. Would you guys rather go an hour earlier? Would that
I
perturb
would.
anybody?
Yes.
Yeah.
Yeah, I'd be willing.
Okay.
8 o'clock is good for me, but I'll be flexible.
Okay. Okay. Yeah.
That
So
would-
we do quite a few East Coast folks, right? And so that means 10 o'clock for you guys, right? Or it's 8 o'clock Mountain Time.
Okay.
So yeah, thank you, Conwar. Yeah, so let's shoot for an hour earlier next week. I'll
Sounds
send her on a
good.
reminder.
Sounds
Okay.
good.
All right.
Okay, thank you very much.
Thank you.
so much, Steve.
Great to
Yeah.
see you all.
You.
Wonderful.
Well, thank you, Steve.
Have red
Have a good
wine.
evening. Yes, sorry. The table's getting set around me, so it's nice outside here. I'll see you all next Monday
Okay.
at kind of 7 p.m. Mountain Time. Okay.
Good night and good luck.
Thank you.
Thank
I'm
you.
going to stop recording.